So student, it is already 4:01. I think 60 students have already joined. So 55 students have already joined. So I think you should start. Okay. So Amurtha sir has already joined.
Okay, so Omi and Diditi.
Okay, sir. So should we start now?
Yes, yes, sure. Start.
Hello, everyone. A very good evening to all the attendees. Welcome to the third day of the Innovation and Entrepreneurship Workshop series. A very warm welcome to Professor Amurtha Mukherjee, our honorable speaker for the day. And I thank Professor Dibakar Roy Chaudhary, Professor Arun Kumar Chatterjee, and other professors present today for their precious presence in this session. I am Shomi Roy, a member of IIC, IEM, and along with my senior, Didi Shadu Khan, I'll be hosting today's session. Professor Amurtha Mukherjee is the head of the Department of Computer Science and Engineering, AIML, and CSBS at Institute of Engineering and Management, Kolkata. His primary research interest is in Internet of Things, mobile ad hoc networking, delay-tolerant networks, embedded application development, and machine learning. He has written several research articles and books in the field of IoT, 5G wireless networking, and embedded systems, and published his work in renowned journals such as IEEE, Springer, CRC Press, that is Taylor and Francis Group, Elsevier, World Scientific, and IGI Global. His book, Embedded Systems and Robotics with Open Source Tools, is one of the best-selling books in the field of embedded application development. That was a huge list of academic achievements. Without doubt, I can say today's session is going to be one of a kind. So with no further delay, I would like to hand over the session to Amurtha sir.
Thank you, Somi. I guess I'm audible. Am I audible to you?
Yes, sir, you're audible.
Okay. And I think my screen is also visible.
Absolutely, sir.
If it is so, then we can start then. So, hello everyone. First of all, a warm greeting to all of you.
If your screen is not visible, if you have shared something.
No, I'm not sharing right now.
Okay,
I think my camera is visible.
Yes,
so...
camera is
Okay, fine. So we'll start the session now. So first of all of you, just a warm welcome to the session. And today we will start talking about the IoT. Rather, we can say that the problem solving aspect of the IoT, because IoT is a huge field, and we definitely need to have different type of problems when we develop the IoT applications. So how we can actually go for those problems, and what are the approaches we can take in order to solve the different applications and IoT that we are going to discuss today. Okay, so let me share the screen now first. All right. So my screen is, I think, visible to all of you. If it is not, then please let me know so that you can adjust it.
Yes, sir, it is visible.
Okay, so our today's topic is the problem solving and the formulation on Internet of Things perspective. Okay, so definitely this IoT concept and this IoT paradigm is a very cutting edge, and you can say it's a kind of a buzzword nowadays. That Internet of Things applications, smartphones, smart devices, smart robots, smart industry, smart city, everywhere you can see there are numerous applications of this IoT. Okay, so what are the different kind of problems? What are the different kind of things which we are actually dealt with in order to formulate the problems or formulate the solutions corresponding to the problems? All right. So first of all, at the very beginning, we should start with the terminologies, that what is basically the IoT. Okay. So what are the key component of IoT, if we consider that an Internet of Thing kind of a thing, then what are the key concepts? Basically, there are 4 very important concepts up there, right? First is the IoT system. Whenever you are designing an IoT, it should support the machine-to-machine communications. That means what? Suppose you have a machine, like at your home, might be you have your smartwatch, or might be you have a mixer grinder, or you might have a, say, radio. So what the IoT does, basically, it can able to give you a opportunity so that you can communicate between one device to another. Might be your mixer grinder can communicate with your smartphone. Might be your television can communicate with your fridge. Might be your fridge can communicate with your mobile phone, and something like that. Okay. So this is the main concept of IoT that we are actually considering. Definitely, the two-way interaction is one of the key components. That means from one device to another, then definitely from another device to another device. So this is one of the challenge. Further, along with the communication, another very important aspect that is also taken care of is the processing of the data. That means whenever you are taking the data, suppose you are taking the data from mixer grinder, you have to process that data, might be at your smartphone. Or might be you are taking the data from, say, fridge, that what is the current temperature and what is the status of your food present in your fridge. You are gathering the data, and maybe you are computing all these things into your smartphone, or might be in your smartwatch. So that means you need to have the processing capability into the edge of the network. That means at the bottom of the network might be, as well as in the cloud as well. You also have to do some actuation between the different devices. Might be, suppose, from your smartphone, you are trying to control the temperature of your fridge. Or might be from your smartphone, you are trying to control the speed of your mixer grinder. Okay. So if you are trying to do such kind of thing, then definitely it is a part of the IoT, I can say, right? So these are the main things. So key components, right? Now, if we consider the architecture, that if we think in a nutshell that how the IoT is actually look like, okay, so it is a very bare basic, or you can say it is a very common kind of architecture that we are actually dealt with, although we can expand this architecture into further more detail, but for the sake of simplicity, I'm considering this, that what are the different components, right? So from bottom to top, if we consider, we can start with the bottom layer. Okay, so it is kind of, it is you can say that this is basically a kind of layered architecture. Okay, layer 1, layer 2, layer 3, like that. So if we consider from the base layer, that is the ground layer, then that ground layer is those elements which are considered as the things, right? And these are nothing but the sensors, actuators, and all this. Okay, and overall this layer is known as the perception layer. So what are the different things that you can consider in a layer, in the perception layer? The first one, you can say, suppose a smart bulb, right? Might be your mixer grinder, might be a door lock, might be a you can say kind of a doorbell, might be a temperature thermometer kind of thing. So you have a digital thermometer at your home, so that you can consider that particular thing at the perception layer, right? So all these components which we are using in our regular basis, that means in our regular usage at home or anywhere else, okay, all these are kind of things we can consider. Even if a bottle, say you have suppose you have a water bottle with you, and and suppose that bottle is so smart because it consists of n number of sensors which sense the water level of your bottle, and immediately it will remind you to take some water from it. That means it can monitor that how many amount of water you are actually taking from your bottle, so that the water level at your body will get optimized, right? So you can consider that also as a thing, right? So after that, after perception layer, we can go for the network layer, right? So in the network layer, which is a very crucial kind of a layer, where everything, that means whatever the things present in the perception layer, every elements or every component actually generate the data, the huge amount of data, definitely, okay? Because wherever there is a sensor, you can consider that the data will get generated by your system, all right? So if the data is generated by your system, then there might be, or there must be, a means of communicating that data from your perception layer to the higher layer, like application layer. So you must have a communication network system, right? Must have a communication network system. So in order to get that communication, you have to have the network layer, right? So what are the different component of the network layer that I can say? That if you are using a smartphone, then definitely that smartphone consists of a network connectivity. Might be it is a 4G connectivity, might be some case it is a 3G connectivity, but right nowadays in India we cannot think about a 3G. Definitely we can go for the 4G, and even from the next year onward, the 5G connectivity is also going to evolve, because already in today's budget, union budget, it has been considered, it has been announced that the 5G spectrum will be there from the next year. That means definitely you are going to avail that facility of the 5G also in the next couple of years, right? So the network is a very important component in your IoT development in order to make the communications, right? So a big challenge is to create the gateway, right? You have to create a great gateway so that you can take up your data and then go for and just propagate that data into the application layer, right? So this is one of the key components. So what are the real life technologies we are telling already? The sensors, communication networks, processors or edge processors. Sometimes it can be said that edge processor. Why? Because these processing are very, very important in case of IoT. And in the edge of the network, it is always happens, most of the cases. So that is why it is known as edge processors, right? Then, of course, the cloud technology, right? Cloud technology, which is highly associated with the IoT application developments, right? So these are the main components. When you deal with the IoT, definitely we can go for those components for sure, right? So now we are coming into the problem solving aspect of IoT, that what are the different problems we are actually finding in order to develop the IoT applications, right? So the first problem that we can face is the designing of the architecture, right? So that is a very big issue when you are creating, when you are as a developer, as an IoT developer, you are joining into an industry. Your first challenge is to design the proper architecture for the IoT system that you are going to implement, that your organization going to implement. Suppose you are getting a project from USA to make a home automation system. Now you can make the home automation system by using various kind of technologies, but which technology is the suitable for your application aspect, that we need to understand. Okay, so that is why the architecture design is a very important problem solving approach, right? And the second form, the implementation of the components, okay, because naturally when you deal with the architecture, might be this architecture is a very compact kind of architecture in some cases. Might be you are developing your IoT application for an industry. Suppose it is an industry 4.0, so you are making an industrial IoT application. Then definitely the component which are actually useful for that particular industrial application, that might be differ, or most of the case, 90% of the case, it will be differed rather than or differ from the application that you are making, or suppose for a home automation. So if you are making a home automation IoT and if you are making an industrial IoT, the two things are actually different, right? Two things are actually different, right? So that is why the choosing of a proper component, implementation of the proper component is also very much important. Okay, and this is another very well-known problem aspect when you are developing the IoT applications. Third, the application level deployment itself is also very important because see the IoT, when we are creating the IoT, this entire thing is not like only a simple hardware component or simply the software component, right? So whenever you are making an IoT application, it's basically a giant. It consists of numerous hardware components. It also consists of numerous software components as well. Okay, so it's basically a amalgamation, you can say, combination of the hardware component as well as the software component, right? So it is a combination of hardware and software component. So therefore, whenever you are designing and developing this IoT components, in the application level perspective, you also think about what are the different components you are amalgamating and what are the different components you are using currently, right? So whenever you are developing which application and what are the components you are using as an application level is also a very important aspect of the development and the deployment of the IoT, right? So it is a very important challenge. And finally, the service and the maintenance, because as you are developing the entire IoT ecosystem for a particular application area, might be for an industry or might be for a smart city. So parallelly, where you have to consider about the service and the maintenance of the system, because if we do not give a proper service, then definitely as you are become a maybe you are become a service provider, or might be you are the vendor and you are not giving proper services to the clients, then definitely it will be not very much accepted thing. Okay, so being a service provider, being a client, being a hosting service, you definitely have to give some aspect of service and maintenance to the clients. Okay, so how you are designing the service management, how you are designing your maintenance strategy, maintenance policy, that you have to identify. Okay, so that is one of the big problem formulation aspect of the IoT also, right? So these four components, perhaps the most important component if we consider the IoT problem solving aspects, right? So we will just start discussion about the first implementation, that what are the design architecture of designing constraints and the problem that we are facing during design. So that is our first stage of interest. Okay, so let us jump into that first. So what are the architecture? What are the possible architecture that we are actually trying to implement, right? Architectural formulation, you can say. The first kind of architecture, which is very much very common IoT application. Whenever you are might be in an undergraduate study or might be in a postgraduate study, and your professor might be give you some project or assignment that you have to make IoT application, a simple IoT application like home automation or something like that. So this architecture, this is a very bare basic kind of an application that you are actually trying to make in this case. So what is that? That is the simple device to cloud architecture, right? We are creating a device, might be it consists of a sensors, it might consist of an actuator as well, but it will directly interact with the cloud, right? It will take the data, gather the data from the sensors, and immediately it will feed the entire data into the cloud. Okay, so that means what? That means it is a device and there is a cloud. That means one device and one cloud is there. Then we can go for second version, that is device edge cloud. In the third version, device fog cloud aspect, that is the third version. And final version, that is edge dew fog cloud, this ecosystem. Okay, so these are the primary architecture formulation that we can go for. Okay, so if we consider the first one, the architecture of the first one, then that will be looks like this. Just a minute. Yeah, this one. So simple device to cloud application, right? If we, most of the case, 90% of the cases, when you are in the undergraduate study or in the postgraduate study, we will generally focus on this kind of architecture. So what is that? Might be it is a sensor, you have the sensor. Might be you have any other kind of devices, might be it a smartphone or any other devices might be, okay. So what it does, it actually sends the data and then send that particular data into the gateway. And then the gateway is basically nothing but an internet gateway. So through the gateway, you can just push your data directly to any cloud service. Might be it's a AWS or might be the GCP platform. So you are just push that particular data into the cloud service directly, right? So when you are sensing the data, it might be a scalar type of sensing, or might be a vector sensing kind of a thing. Might be, suppose you are sensing the temperature data, then definitely it is a kind of a scalar kind of a sensing. That is a single quantity is only there. That is a scalar quantity only, right? Now, suppose you are using a gyroscope or maybe some MEMS kind of sensors, to which you are not only sensing the direction or orientation, but also you are sensing the speed or something like that. Okay, that means you are trying to sense some directions by using the accelerometer gyroscope, kind of an inertial measurement unit. So if we use that, then definitely those are the vector data. So those can be considered. And by using the smartphone, you can do that very easily. The inertial measurement you can do. So these are the vector kind of data. So all this kind of data you can send and then feed it through the gateway to the cloud directly, right? So this is one of the, you can say it's one of the typical example that how you can manage the device to cloud. That means you are sensing, you are sending the entire data through the gateway, and it will be go directly to the cloud, and further processing whatever you are doing, it is in the cloud itself. Okay, so only within the cloud only the things are applicable, right? So this is one of the very bare basic device to cloud architecture that you can do. Secondly, if we go for the second applications, now this application is kind of, you can say it is a typical industry oriented somehow. It is not a very basic architecture, but it is having some very essential component which are relevant with the edge level processings, right? So you can see here, these icons looks like graphics cards. So these, you can say that these are the edge processors. Okay, these are the edge computing devices or edge processors, which might be attached with your smartphone, might be attached with your car, might be it is with any other component, like might be a traffic signal or something like that. So what it will do, whenever your perception layer components like your smartphone or might be your car sends some data, that data might process into that edge layer. Okay, it might process into the edge layer. And that means what? That means before you are sending it into the cloud, you are processing at the edge layer. So what it will do actually, it will do some pre-processing activities into the edge layer, right? It is doing some pre-processing kind of thing in the edge nodes. Okay. So in autonomous car, generally we can do this kind of thing often because it will must have some real-time decision-making capability when you are dealing with the autonomous cars. So it is one of the very good example of the edge computing. That is whenever you are doing some processing into the edge layer, right? And after that might be the pre-processed data, you can send it to the gateway and you are sending further into the cloud layer, right? For further processing, that means might be sometime it happened that you have to have the historical data analysis. Like say for a traffic signal, it will always come. That is sometime you can see that in the traffic signal also the CCTVs are attached, and CCTV actually catches all the activity of the traffic. That means ongoing traffic, up and down lane, and further it might process in the cloud layer for identification of the those people which are exceeding the speed limit or something like that. Okay, so that can be done further. So they can be also done into the cloud layer, right? So this is one of the architecture which is all very popular architecture for a very fundamental level cloud development or IoT application development in somehow industry level standard, right? So this is one of the important or second important aspect. Then from that we can add one more layer, right? We can add one more layer after the gateway, right? So these three components are intact, but here you can see after gateway we have a fog node. You can see after gateway we have a fog node. Now what does it mean, fog? What is a fog? Now fog layer is basically layer underneath of your cloud, right? So if you consider the entire thing kind of in a atmospheric point of view, then you can understand that cloud is at the top. It should be always in the edge or in the end of the stratosphere. Definitely in the from the troposphere to stratosphere, and fog is also always in the troposphere, right? So that means what? That means it is always inside, or you can say underneath of the cloud, right? So fog is basically a concept which is very much important nowadays, so that you can actually split up the activity, or you can say the functionality of your cloud, and send some part of functionality into nearby fog layers, which is somehow nearby your gateway, or you can say somehow nearby with the edge. That means whatever pre-processed data you are actually gathering into the edge nodes, they can migrate into the fog layers. Okay, they can migrate into the fog layers, and in the fog layer you can do further processing, which might be a critical processing for a particular instance of time, that can be done into the fog layer as well. Okay. So what is the advantage of that? The main advantage is that it will reduce the load on the cloud, because see, when you are using AWS or GCP platform, definitely AWS actually gives the support throughout the globe, right? So definitely it having a huge load. That means at a time, huge number of requests are actually going to the AWS, huge number of requests are going to the GCP, and definitely as a result of that, the cloud architecture itself might be exhausted sometime. Okay, although there are various type of scheduling techniques are available into the system, you can dynamically make an elastic cloud as well, but for some particular application, might be for a very kind of critical applications, we sometimes we need to extend the cloud into the fog node so that it can balance the load between the cloud layers. Okay, so that is why these fog nodes are very important, which is always use some of the part of the processed data. That means, or might be you can say kind of pre-processed data, and process it within the fog node, and it might be most of the case the critical processing, right? And after that, further processing, maybe in a detail level processing, we can send the data into the cloud, right? So we are not giving entire load to the cloud, rather we are splitting the functionality into fog and the cloud, right? So this architecture is a quite standard architecture for various applications. Like if you go for a smart city application, Industry 4.0 application, most of the industrial IoT are actually believes on this kind of architecture. Also, for smart society applications, you can deploy this kind of architecture. Okay, so whenever your problem is a huge, that means you are covering a huge problem domain, then definitely you have to split the architecture accordingly. Okay, you have to split your architecture accordingly, right? Because if say in a smart industry, if you are trying to make a simple device to cloud architecture, it is not actually, it will be literally, it will not suck. Okay, because the number of tasks, number of applications, number of appliances are huge, right? So, and the first architecture cannot give you that ample support for that. Thereby, we can go for such an architecture which is even more vast, even more dense, right? Or more number of appliances can be supported by using this particular kind of architecture, right? So this is one of the important architecture, the edge fog cloud aspect, right? So edge fog cloud is a very standardized architecture nowadays. Most of the applications, most of the industry standard applications, IoT applications are actually believes or run within this architecture, right? So we can even extend this architecture to the maximum extent, right? So how we can extend this? This can be extended into with this particular formation. Now, this is a quite crucial, and this is basically under research stage because some of the features of IoT, which is a very giant research problem, and that whenever we are using the things, that means whenever we are making every component connected with the internet, then there are some crucial problems that actually arise. Okay, so I think some of you may heard about another term which is known as the Internet of Everything. So Internet of Thing is there. There are other crucial things like also there, like Internet of hospital things, Internet of healthcare thing, Internet of medical thing, Internet of vehicular thing, Internet of drone things. Okay, so these are the very well-known nomenclature nowadays. Now, along with them, another very important nomenclature is the Internet of Everything, right? Internet of Everything. So you can easily understand that if we consider Internet of Everything, it means that at every aspect of our society, in every aspect of our technology, we are incorporate the Internet of Things. That means every device, everything in our world might be connected with the internet. Okay, might be connected with the internet. So it is a giant approach, basically. It is a giant ecosystem, you can say. So in order to realize this, problem, you have to formulate the solution accordingly. Because, see, if we consider the different kind of communication technology also, suppose currently we are using 4G communications. Okay, So 4G communication, you are using Geo network, you are using Vodafone network, you are using Airtel network. Most of them are 4G networks nowadays. So suppose a scenario that you are in a ship in a vast ocean, and you want to make a connection with your friend via the WhatsApp chatting. So it is very difficult. It is very hardly possible. If your ship has inbuilt Wi-Fi, then that Wi-Fi should connect with the satellite communication. Then you can only send your data, right? Suppose you are traveling through the airplane. Okay. From say you are just starting from say Mumbai airport and you are going to New York. Then definitely within that particular in your travel, if you consider, then most of the case you are not going to get the proper internet service during your flight. Might be in some cases you are getting the service through the internal Wi-Fi, but it is limited, right? But the Internet of Everything aspect, if you consider the Internet of Everything aspect, then definitely it will give you the internet connectivity in everywhere. That means within the deep ocean, during the flight. If you are in the underwater, suppose you are traveling through a submarine, also you must get the internet connectivity over there. Okay. So is it possible? The answer is yes. Answer is that it is possible, and researchers are actually doing enormous amount of hard work to achieve these goals, right? So this kind of problem, you have to formulate this kind of problem in such a way that you need to achieve this goal by applying the proper technological component into the IoT, right? Now here you can see that I am using this edge node. The edge processors are there. We have the gateway, we have the fog node, but along with this edge node, there are some dewdrops are there. So you can see the dewdrops. These dewdrops, this is basically kind of a, you can say for the example I'm just taking this dewdrop. These dew nodes are also kind of a node. It's kind of a hardware device which can buffer your data actually, right? So dew nodes are those nodes which are present between fog, your IoT gateway, and the edge. That means in between them, there's a middle layer, you can say, which is known as the dew node, which can buffer, you can store the data temporarily when your connectivity is pretty much intermittent. Okay, because see, if we are in the air, then definitely it will be very less possibility to get the internet connection always. So that means that your connectivity is intermittent. So suppose you are just encountering to a particular satellite location, then your data is get flown through the satellite to the cloud. Okay, but within the denial zone, or might be in the blind zone, whenever your aircraft is flying in a blind zone, that means there is no internet connectivity is there. Then what it will do, it will actually buffer the data into a dew storage, and it will fill or acting like that you are even connected with the internet, right? So something like that. You are when you are running the YouTube, you can see that sometimes your YouTube is buffering. Sometimes if the connection is very good, then definitely it will store the video stream into your system temporarily, and at this point, if you just switch off your internet, you can get entire video, right? So that means what? That means it is actually buffering. So this particular concept is a very important concept when you are developing the IoT also. Okay, so you are just adding this dew computing phenomena with the edge nodes, so that some of the data are get stored into the due node, and even if the internet connectivity is not available, it can avail that data, and then it can process that data as well, right? So this is one of the important feature of the due computing that are ongoing. Basically, the research is ongoing. This research has no limit, no end. So you can deploy this due node at the edge end, even if you are deploying that particular due node in the fog level as well. Okay, so that can be possible. So this is one of the very important, or you can say one of the very challenging aspect of IoT ecosystem or IoT architecture development. Okay, so I hope it is quite clear to you that what are the different problem formulations that we can taken care of. Right? We also have the problem which need to solve in case of network design as well. Okay, so network design is another very important aspect where we can go by. So in normal case, when we use the internet, your internet technology, we are either use 4G technology nowadays. 5G technology is coming, so we can consider the massive MIMO technology over there. Then we can go for 6G technology. Might be next couple of years, might be after 10 years. You can see avail the 6G technology, where the MIMO is not a simple; it is a ultra massive MIMO. So MIMO stands for multiple in, multiple out. That means multiple number of frequency can get in and out at a time. So that is why MIMO. Okay, so this is one of the highlighting aspect of the IoT problem solving, because whenever you are your number of device get increases rapidly, because you can easily understand that nowadays we might have 4 or 5 smartphone at our home, but if you go for in 10 years back, then definitely we might hardly have one mobile phone. Okay, so that means number of smartphone increases. If the number of smartphone increases, then definitely we need to have more number of bandwidth. We have to have more number of frequency slot. So that is why 5G is actually coming into picture. Even after 10 years or 15 years, it might have that 5G network is get exhausted. So in that case, we can go for the 6G network. And as a matter of fact, we can say that if we are considering the network for at everywhere, that means internet of everything aspect, then definitely we will have to shift from 5G to 6G, right? So 5G is not enough for internet of everything. Okay, if we want to get an internet at underwater, if we want to get internet at deep space, if we want to get the internet at in the huge ocean, then definitely 5G is not sufficient. So we have to go for the 6G. So that is why these are the very key problem, or you can say the very, very important aspect of problem solving in the design of the IoT applications, right? So after that, what we can say, we can go for, we can go for network topology design. This is another important aspect for Internet of Things, because in case of IoT, the nodes that we are considering, the nodes might be static or might be dynamic, because you know that if we go and consider the smartphones, any smart device, smart watches, the devices are dynamic, right? So that is why the designing and identifying the proper topology for a particular IoT application is also very important. Okay, so if you have the dynamic topology, then definitely it is always changing topology, and if it is a always changing topology, then data transfer within that particular topology is also very challenging, right? So definitely our mobility modeling will help us to identify that how we can make the data transfer from one device to another device, right? So this is one of the very important problem formulation. So we have to go for the mobility modeling, proper mobility modeling. Okay, so it will give you the clear picture of the mobility. Okay, Also, it will able to track the ability of the data transfer, that how fast you can do the data transfer. Okay, suppose you are using a normal, say, mobility, random mobility. That means, say, suppose two devices moving randomly in a particular room. Then you might not predict that how, in which order you can transfer the data, because you do not know that whether they are connecting in a particular instant of time or not connecting in a particular instant of time. But if it is a properly mentioned mobility, suppose you are using a shortest path mobility, then definitely shortest path mobility, it is very much predictable for that one particular node will always keep a shortest path from the source to destination, so that if we have multiple number of node in a shortest path, then definitely they will do the data transfer pretty efficient. So that is why this is one of the very challenging problem solving aspect of the IoT, that how you are designing the mobility model for IoT, right? So this is one of the important aspects. We also have to have the protocol selection, that what are the different aspects of protocol selection. In general, these are some examples. Messaging protocol that we are using for for IoT is the MQTT and MQTT-SN protocols. Okay, so MQTT is known as the message queuing telemetry transport. MQTT-SN is the same thing, only for the sensor networks, right? So this is MQTT-SN. We have to have the real-time streaming protocols also, like your RTSP, RTMP protocols. Real-time command transmission protocol in some cases. Suppose in nowadays you can see that small drones you are actually can connect for photography, and then you can send the data from the drone to the base stations. Okay, so for that, if you want to control that particular drone from the ground through your smartphone or something like that, you must have a Mablink protocol over there. Okay. So Mablink protocol is a very important protocol if you want to create an internet of drone things, right? So you can do that. So selection of the proper protocol for the proper IoT application development is a very important. Okay. So this will help you to identify that what is your problem statement for your IoT application development, and what are the possible solution you can provide in order to reach that problem. Okay, so that is one of the some very specific or fundamental aspect I am just taking, right? Then we can go for SDN and slice, although it is very deep research field actually, that's SDN and slice, because since we are coming into the 5G networks, so in the realistic IoT application development, we need to segregate the different application aspects also. Okay, that means suppose we have a particular IoT application which is completely solely designed for hospitals. Another IoT application might be completely designed for the industry. Another might be for the traffic management. Okay, so say n number of IoT applications are there, and they are using the internet. Always they are using, they have to use the internet, right? In case of 5G, if we consider the 5G internet, then one of the very important concept of the 5G is that we are creating the internet system, or you can say the network system, not only by using the hardware itself, but also by using the software itself. Okay, that means these kind of internet are known as or you can say the networks are known as the software defined networks. Okay, so SDN is basically software defined networks. Okay, so although it looks like a physical network, but basically that network is not a hardware network. It is a software network which are using some component of the hardware. Okay, it's a kind of a virtual machine. Okay, so in case of computer, sometime we use the virtual machine like Oracle virtual station, or might be your VMware. All right, these are the virtual machines. So like that, we can also create the virtual networks. Okay, it is known as the next network network function virtualization, NFV, right? So this NFV is a part of software-defined network. Okay, so by using this kind of technologies, basically we can use the same network infrastructure, same hardware infrastructure for different type of application, okay, and each and every applications might allocate some set of resources, right? So those resources here are virtual resources, and those resources are known as the slices here. Okay, that means suppose, as I'm already said to you, that you may have a application which is dedicated for the healthcare. You may have an application for traffic monitoring, suppose. You may have another application for, say, online shopping. Okay, so those three applications might use the same network structure, but virtually they are get segregated by considering the slices. Okay, so these are the concept which are actually emerging concept in our 5G network. Okay, in 4G network, generally we do not bother about this slice and all this, but for the 5G network, we will consider this net SDN and slices. Okay, so these are also very predominant research challenges, right? It's a very predominant research challenges in our IoT problem solving aspect. Okay, so this is one of the important thing. We can consider this as a Sdn modeling. These are the different kind of a slice. This is a virtualization basically. So whatever it is written over there, it is the pictorial form of this particular thing. Okay. Now we can go for the application development concept. That means what are the different application development frameworks are present, right? Because this is how these are the tools through which you can actually develop your IoT applications. So AWS IoT is a very popular. IBM Watson IoT is there. Device Hive is there. ThinkSpeak is there. Then your Eclipse IoT is a very important IoT development tools. You have Node-RED also, Node.js based IoT development tools. You have GPredix. GPredix is mainly used for industrial IoT applications. So we do use all these IoT application development frameworks in order to develop our IoT, right? So I just want to tell something about the IoT application development frameworks. We may consider the Node-RED here. Okay, so we mainly focus on the Node-RED. So why we are going for Node-RED? Because Node-RED is an open source application development framework. There are other application development frameworks are there, but I found that Node-RED is a very simple and realistic IoT application framework, right? So Node-RED is basically an open source. It is a flexible, very flexible. The application can be deployed very easily. There are a wide range of hardware support is there. That means if your device is able to communicate with the serial port communication, then definitely you can easily deploy the application, IoT application. Okay, like suppose in case of Arduino, we often use the serial port links. So we may use the Node-RED application development platform. Okay, so suppose if we consider here is the snapshot of the Node-RED application development framework. So I can give you some hands-on experience on that. Okay, so one of the applications, sentiment analysis, which is a very common application we might use sometime, because you know that in IoT or in different data analytics, if you consider the data analytics field, then of course the sentiment analysis is a very important term, right? So we can go for the sentiment analysis, that how you can create that sentiment analyzer application using the Node-RED, right? So let us have a look. So we can go for that. So here it is, you can see here. So this is our Node-RED application. This is basically an open source application, you know. which can be found in this particular website, node-red.org. This is the website. It is freely downloadable. Only thing is that you need to have the Node.js framework with you. That means you have to install the Node.js framework first, and after that you can run this Node-RED into that. So what are the support? You can see here, Node-RED can run locally. Node-RED can run on a device. That means it might be kind of an edge device. It might be run into the cloud itself, right? So IBM Cloud is directly, it will be run in the IBM Cloud. It might be also support AWS. Also in Microsoft Azure, you can directly deploy this, right? So you can get it with the local form of the instances, something like that. Just directly click on this. You can see that how to install the Node-RED that is already mentioned over here, that you just write sudo npm install -g unset pim Node-RED. So if you do this in your command line argument, then it will install the Node-RED for you. It will install directly from the cloud. But before that, you have to install the Node.js framework. Okay, so I think most of you know that what is the Node.js framework actually? Node.js. So you can write node.js here. So you can download the Node.js version recommended for most users. So you can just download it and install it like an application. And after that, you just install this Node-RED by using this command. Just copy it and paste it into the command line and it will get installed, right? After that, what you need to do, you need to run your Node-RED server. Okay, so basically it is a server-based application. So for that, in the command line application, command line CLI interface, we just write this Node-RED command. Okay, so here it is, Node-RED. So you just write node-red and then press enter, and it will start the server itself. And you can access the entire resource into this with the address like this 127.0.0.1:1880. So this is basically the loopback address. This is the local machine address. So the port is 1880. You should know that it will be run in the port 1880. When you start your Node-RED, it will also showing right here that you can see the server is now running at HTTP 127.0.0.1:1880. So this is the default path, default URL for our Node-RED application server. Okay. So after doing this, definitely you can go for the application development. So you can see there are different nodes are there in the left column. So here are different functions and features are there basically. So if we want to avail these features, you can just directly press or click it and then drag it into your area. Okay, so this area is the application area, so you can drag and drop it, and then you can connect all the nodes with any other nodes by just dragging it, right? So you can see there is a connectivity established between this button and this person. Okay, so in this way you can actually connect all these applications. All right, so my intention here is to just show you, just make a showcase that how you can make a simple IoT application. It is basically a sentiment analysis application. Okay, so this sentiment analysis, I am taking the sentiment analysis application by considering some news which has been present into the CNN website. Okay, so in CNN website, if you see in the CNN website, they will send some RSS feeds. You can subscribe to those RSS feeds. So what is that RSS feeds? Anybody can tell me? This RSS is basically a really simple syndication through which some real-time news or real-time update you can get from any website, right? So this is a very important thing. So what we can do in this application, we are just taking the RSS feeds from the system, from the CNN website itself. You can see that URL is there, http://rss.cnn.com, then editionworld.rss. So we are fetching that particular news feed from the website, and then we are sending that to the analyzer. Now this analyzer node here is basically a sentiment analyzer, right? So what is the task of this sentiment analyzer? The task of this analyzer is to analyze that whether your news is a positive sentiment news or a negative sentiment news. If it is a negative sentiment news, then definitely it will give you a score less than 0. If it is a positive sentiment news, then definitely it will give, say, the analyzer will give you a score greater than 0. That means 1 to 9 mostly. And if it is a neutral sentiment 0, then definitely it will be give you a 0 value. Okay. So suppose that that COVID, suppose considering that the COVID virus news, suppose a news is coming that COVID virus is affected throughout the world and the death toll is increased to millions. So definitely it is, as the death toll is concerned, so definitely it is a negative news. So in that case, it will definitely give you the sentiment, negative sentiment there. Okay, so that is the minus value. That means less than 0. Okay. So in this way, this application has been designed, and finally, the output has been generated into the as a text, as a sentiment value gauge. You can consider, right? You can even consider the audio or something like that, or even you can store the data of the news, whatever you are taking, right? So it is a very kind of a application. I will definitely give the detail of this application further because there is no time to explain in detail about this application. So you can see that at this moment, if we consider another window, I'm just giving, just showing the output of that particular application. So just copying that particular URL and pasting here with UI /. So you can see that here is basically the output of your values. Okay, that means whatever the data it is taking, it will analyze the sentiment. So the sentiment of the news is positive and the value is 1. So it will actually showing in the gauge, right? So it is a real-time analysis. Okay, so whatever the news is coming and in CNN at this moment, it will just fetch it from through the RSS feed, and then it analyze the sentiment of that particular feed, and then it will immediately showing you that in a graph that the value is positive and the value is score is 1. Okay, so that means the positive sentiment news is coming at this moment. Okay, so in this way, different type of analysis you can do. It is a simple IoT application, even if you can connect the device with at your home, and then you can do the analysis also. Okay, so this is about the simple IoT application development framework, right? So I think it is somehow useful for you. You can go to our resources. We have some books with us. So you can go into the Amazon.com and you can see all these books. Resources are there, which might be helpful for your further IoT application development and the different problem solving approaches, right? So up to this, it is fine. So we can now conclude my session. So we have a question answer session right now. So anybody of you, if you want to have any question, you can ask me.
Thank you, sir. That was a really informative session. We would like to move on to the questions now. Shaurya, are we getting the questions on the chat box?
Yes, we will be getting the questions very, very soon, I guess.
Okay.
Thank you, sir. Thank you so much for such an informative session.
Yeah.
Even I got to learn a lot of things.
Yes,
Yes,
definitely.
absolutely.
Definitely. These are the recent trends. So definitely all of the people, all of the students, all of the researchers which are very keen to develop the IoT applications, then they will must have to know all this recent aspect of the IoT.
So the session is now open for the questions. So if anybody wants to ask any question, you can write in the chat box and I will take the questions and say it to sir. You can also send the question directly to sir or to Somi. I think Arun
I,
sir wants to say something. Sir, can you please proceed?
yes,
Yes,
yes.
good afternoon to everybody. Thank you,
Good
Amata
afternoon,
sir,
sir.
for your wonderful lecture.
Yes. Thank you, sir. Thank you.
So
Thank you
my
very much.
question actually is more from a student's point of view.
Yes, sir.
That I believe that in these study of these branches of engineering, a lot of mathematics is involved.
Yes,
And
definitely.
as a teacher of mathematics, normally I am confronted with a question whenever any new topic is started. What are the applications?
Yes, sir. Yes,
So,
sir.
my question is very focused. Whatever you have covered, do
Hmm.
you think that the study of vector spaces is more relevant, or is the study of graph theory more relevant, or
Mm,
are both of them important?
Yes, sir, definitely. The vector space and the graph theory both are very important because, if we consider the sensing part, then definitely we need to have some idea about the vectors because there are different type of sensors. Most of them are vector sensor in this aspect. Okay, so definitely the vector space is very important, and graph theory is rather more important because as the network is concerned, because IoT is consist of enormous number of networks, and might be the topologies are dynamic. Most of the cases the topologies are dynamic. So as there's a dynamic, then definitely we need to create the proper mobility model, and for that definitely we need to know about the graph theory. We need to have the idea about the shortest path algorithm, the depth first algorithm, breadth first algorithm. We need to have the greedy approaches because greedy approach are very well-known approach in order to develop the mobility models and the mobility patterns of the nodes, right? So this is one of the very important aspects. Even my PhD research is on that also, that is the mobility model. Gauss-Markov mobility model is a very important mobility model, okay, that we are dealing with. So for that, definitely the graph theory is a highly relevant with the IoT application development.
So I will carry on
Yeah, yes, sir.
with one more question.
Yes,
Pardon me,
yes.
because
Yes, sir,
I know
yes.
nothing about anything. That is what I always believe in. In your lecture, I found this two words,
Yeah.
edge and node,
Yes,
which
sir.
also
Yes.
come in graph theory, but I believe that this is used in a different sense. Am I right?
Nodes are the same thing that we are using in the graph, because nodes are those which are the entry point, or you can say the point, junction
Okay.
point between the different edges. Now here the nodes are something similar with that, because here nodes are the point where the data is collecting, right? And these nodes are having the capability to storing the data, or sometime it might be able to store or process the information, and then it can propagate to the different other nodes as well. Okay, so node which we are considering over here is similar with the node that we are using in the graph theory. Okay, sir.
Okay.
And
Last question
yes, sir.
before I hand it over to the students, because their question will be more relevant than mine.
Yes, sir.
When you talk of flow of information, we talk of the shortest path algorithms. So
Yes, sir.
is it that you always use the Dijkstra or Prem or Kruskal
Yes,
or
sir.
whatever?
Yes, sir. Yes, sir. My one of my research paper is actually using the Dijkstra algorithm in order to find out the shortest path for the flying ad hoc networks, and which is often relevant with the Internet of drone things. So we can use this Dijkstra shortest path algorithm for that. So that is a very relevant. Yes, sir.
Okay, thank you very much.
Okay, thank you.
I'll hang on for the other questions of the students and the answers you give. Thank you.
Yes,
Thank you.
yes, sir. Thank you. Thank you.
Thank you, sir. We have a question from Rehan. Sir, you did talk a lot about IoT. We would like
Yes.
to know what's your take on Web 3.0 and blockchain technology?
Yes, see, I'm not very much fond about the Web 3.0, but definitely the blockchain technology, which is a very relevant part with the IoT, because since the IoT is concerned, each and every element, each and every devices can connect with the other device. That means there is a basically open network connectivity between the different devices. So as the open network connectivity is concerned, then definitely the security issues are very, very much important. Most of the nodes are vulnerable to the attacks. So definitely we can go for the blockchain and all the security firewall systems, and we must incorporate them. Okay, and there are huge researches are going on actually, that what are the different kind of security aspect and security threats are there in the IoT, and definitely we can solve them by using different type of security aspect. Most of the cases, the blockchains are very much relevant for that. Okay.
There's another question from Rehan. Rehan,
Yes.
can you please unmute yourself and continue with the question?
Yeah.
Hello.
Yeah,
Good
yeah.
evening, sir.
Good
First
evening.
of all, thank you so much for letting me to speak here, and thank you, Sharada, for giving me this opportunity.
Yeah.
So today, actually, another question I had that, is it really a good decision to store all the important data on tech-based stacks such as blockchain technology or something like that? Because just now, lately we have seen that CBSE has shifted its board marks, all the data related to board to the blockchain technology, and now the world is sufficiently aware of how technology can be manipulated, if not today, then tomorrow, because technology has sufficient number of loopholes.
Yeah, exactly.
Is it really good decision to take everything on a digital space? Because I think, sir, like if you go deeper into this, then you realize that as much number of boons we have, there are equal number of flaws as well.
Exactly. What you are actually telling is quite relevant, because everything nowadays are actually going into the digital space. Therefore, digital attackers are even more ample amount of digital attackers are also there. So it is quite relevant, definitely.
Yes, and another question that I had, sir, that we are all aware, sir, that how cryptocurrency was banned in India, still is banned in India.
Yeah.
And today our finance minister has announced in the union budget, you must be aware, that now from now onwards, 30% tax will be imposed on digital currencies and digital assets. And now she's the government of India was first denying the acceptance of digital and cryptocurrency, to be precise. But now they're claiming that they'll be coming with digital currency in 2020.
They are actually making their own digital currency, so
yes,
that
sir, but
you can legalize that.
But my question is that, sir, initially I was also convinced that blockchain is the future and cryptocurrency is the future, this and that. But as the more I dived into it, the more I researched about it, I realized that blockchain is too volatile. Actually, it's hard to believe that it is sustainable. So I just wanted to know your view on this, sir. Is it really sustainable? Is it really something we can trust upon?
See, as per my view, if it is legalized by the entire globe, especially in India, the scenario is quite different rather than the other part of the globe. So definitely it will be very much difficult to tell or difficult to comment on that whether it will be legalized for the entire blockchain thing or entire your cryptocurrency thing will get legalized or not. Okay, but I think that it should be legalized, because it will be a type of communication or kind of
legalizing with 30% imposition of tax is the same as not legalizing it.
You can you are right in that aspect, but it will be, I think it is a bit you can say bit difficult thing to understand.
Thank you so much.
Thank you, Rehan, and thank you, sir. So there is a question from Aman Singh, who is asking, sir, I am a first year student. Which language should I use for DSA?
DSA means you are telling about the data structure?
Yes, sir. Yes, sir. Yes, sir.
Okay. See, data structure is basically a kind of a concept. Okay, so you can use any kind of language, whatever you like. Might be it will be a Java, it will be Python language, or the traditional part is your C and C++. So if as your syllabus is concerned, then definitely you can go for the C and C++. But if you consider the application perspective, then I will highly suggest that you have to go for Python, okay, rather than only with the classical C. It is better to use the Python also as a platform for the data structure.
Thank you, sir. Sir, there is one question by Shayak, and this question is also from me. That what is your take on the privacy with every device around us getting interconnected with IoT? And sir, I being from cybersecurity, I find it really easy to manipulate the IoT devices. So please give your views upon that.
Exactly. See, basically the research is ongoing because there are a huge level of security is actually required, because as you are increasing the number of layers, might be from the perception layer to edge, then from edge to dew, then dew to fog. Each and every layer must contain some means of firewall in that case. So as you are increasing the number of devices, you are increasing parallelly the number of layers. It will be even more vulnerable to attack. So that is why this is a very challenging aspect in this case, that how you can actually make a universal security protocol, universal security framework to secure the whole IoT device at your. It is you can say it is a kind of it is physically it will be very difficult to achieve such kind of security.
Understood, sir. Sir, there is one question from Rudranil Bose. He is asking, sir, that what is the future of drone technology in India?
Drone technology is, frankly speaking, is emerging, but not a very in a very rapidly. Definitely, there are the restrictions, and if you consider the aviation rules in India, it is very much strict rule. Okay, there are means we are also connected with some drone research development team. So here the regulations are very much strict. Even we are trying to fly that drone at a particular field, we always require some your clearance from the local police authority on all this. Okay, so that is why the research corresponding to drone, outdoor drone is mostly majorly restricted to the research institutions like IITs, your DRDO, something like that. But indoor drone technology, which is a very emerging technology. Okay, so if you go for the indoor localization by using the drones. Okay, so there is a very good future of that. Okay, so we can go for that particular projects also. Okay.
Yes, sir. And if your permission is there, I would like to add upon something to this question.
Yes, definitely. Yes.
Today in the budget, I also read that government is also trying to implement drone technology for crops, for the spraying of pesticides, for several surveys.
Yes.
So it is gradually increasing.
Yes, definitely it will be increased. One point of time, it will definitely, we have to increase the drone technologies.
Yes.
Yeah.
So we will be taking the last few questions. We have a question from Parthiv. How can we connect IoT with robotics?
Yeah, IoT and robotics are always connected, because if you go for the industry 4.0, then most of the devices, most of the robotic arms that can be connected, I think you also heard about the robotic surgery. So these are the quite challenging application of IoT. Okay, robotic surgery, then industry assembly line robots. Okay, they are connected with the IoTs also. Okay.
Understood, sir. So now I guess there are no more questions in the chat box. Let me check the YouTube for one, sir, because we have many people over there also attending.
Okay.
I think Rehan has another question. He has raised his hand.
Okay, Rehan, you can go forward.
Pardon me, sir. This will
Yeah.
be my last question.
Yeah.
So you said that someone asked, I think, what's the future of drone technology in India? And you said that it's a budding technology and it will be soon here. So, but India with a population of around 1.4 billion, and how the structure is not that good to adapt with the drone technology, because you've seen, sir, here we have overhead cables running and all messed up. I think it might require a restructuring of the.
Partly true. See, basically there are different altitude restriction of the drones are there, right? So depending upon the different scenario, might be if you consider the smart cities definitely are those cities, there must not be kind of a hanging cable as well. That okay. So if we can consider the smart city application, then drone technology is quite relevant. But if you go for a normal urban area, then definitely restructure must be there sometime. And in some of the cases, might be you can restrict the altitude, that you have to fly beyond that particular altitude, so that the infrastructure, the cable infrastructure, internet infrastructure, or the electricity.
But then if we put the altitude restriction, that the core so like if we are using the drone for camera purposes or for some security purposes, and if we keep a restriction for an altitude restriction, then how are we going to achieve our purpose? We can't capture what's there if we are flying too high.
So on that particular scenario, if you consider this, then definitely restructure is there, but you can restructure your technology as well. Suppose you are capturing the high definition data, high definition image, and then you are sending it to edge level, and then by using a convolutional neural network, you are enhancing that picture, you are enhancing the quality of the picture, so that you can grab more of the definition of that picture. That means your point of interest. Okay. So that is, you can also do. That means technology is actually helping you to solve your problems.
All the technologies are interconnected.
Exactly. That is why I'm telling the edge computing, fog computing, that is why important. Okay.
Thank you so much.
Yeah.
Thank you so much, sir. So now we would like to move forward and towards the felicitation ceremony. Dhriti, are you present over here?
Yes, I am present here.
Okay. Please carry forward the session.
Okay. So now I request Probesh sir to felicitate the speaker. Is he present?
I think Probesh sir is not there.
Okay, so then I request Devakar sir to proceed to do that.
Okay, please share the screen.
Yes, sir. Just a minute, sir.
Okay, so this certificate is awarded to Professor Amartya Mukherjee for being the invited speaker in the Innovation and Entrepreneurship Workshop, a series of 6 sessions organized by Institution Innovation Council, Institute of Engineering and Management, Kolkata, on 1st February 2022. Thank you, Amartya sir, for this excellent session. I have also enjoyed a lot. I am hoping that in near days we will organize again another workshop.
Definitely. Thank you very much.
Thank you, sir.
Thank you.
Now I request the participants to just put their camera on so that I can take a screenshot.
It's a request to everyone to turn on their cameras.
Okay, thank you.
Thank you so much, everyone. And we will join again in the tomorrow's session.
Before that, I say good evening to everybody. Stay safe, stay healthy. Thank you very much. Amartya sir, thank you very much. It was wonderful.
Thank you, sir. Thank you very much.
Thank you. Bye.
Thank you, Arun sir, also, because you have been joining and motivating us a lot during these workshop series. Thank you so much. Sir.
You see, I have network issues sometimes, and then I get worried when I'm not able to join on time. But nevertheless, I want to join every day. Thank you, everybody.
Thank you, sir.
Thank you.
Thank you, sir.
So now if the participants have got the attendance link, they can leave the meeting.